Alright, this is CHFI Forensics, Lab 16, Mobile Forensic Analysis. One, identifying and extracting mobile artifacts. Mobile forensics is one of the most popular categories of digital forensics. It's earned its popularity due to the significance of the data that is created on one of these devices. It can tell a user's location, associates, likes or dislikes, and much more. In this lab, we will take you through a physical image of a Samsung Galaxy S2 device and show you just how much data can be extracted using free tools and some know-how. The physical image is the best extraction you can get from a cell phone, and it's akin to a physical image of a hard drive. Many phones currently in use only support logical or advanced logical extractions, which provides access to a lot of system data. However, the physical is much more complete as it includes data in deleted space. Whenever possible, always try to get a physical image. We will be using Autopsy to process and review the data from the phone. Let us get started by opening Autopsy and loading at FEF. To begin, launch the CSI Linux virtual machine to access the graphical logon screen. Log in as CSI using the password CSI. Once you're logged in, launch Autopsy from the Start menu, Application menu, Computer Forensics, Autopsy, or you can click the Autopsy icon on the taskbar. Since you're already familiar with Autopsy, let's jump right in by creating a case. In Autopsy, say New Case, or select New Case. Alright, let's do log in as CSI. Interesting. Start and Computer Forensics, and then Autopsy. And where's the Autopsy icon? Right there. It's the Autopsy icon. Welcome, in New Case, case name. We're going to call it 4Lab016. Home CSI desktop cases. 4Lab016 home desk top cases. Okay. Single user, and then next. Okay. The next window in the New Case wizard is the optional information window. Here you can type more information about the case and examiner, fill in the information fields, and click Finish when you are done. My name. Okay, finish. The next window in the new case wizard, okay, we did that one. You will now be taken to the add data source, and we want disk image for VM file, and then next. Then we'll browse. And we'll go to Home CSI Desktop Evidence Files for Lab 16. And open. Still thinking. Interesting. Add data source. Let's think about it. Disk image. Next. Browse. This is desktop evidence files for lab 16. That. Open. And then next, probably. The FEF of the cell phone that we use is in this lab is from the NIST Computer Forensic Reference Dataset CHFR Reds at that URL. Image path. Click next. Time zone. Oh. Time zone is an important aspect to any forensic investigation. Feel free to adjust the time zone to match your respective time zone. That is correct for me. We will be taken to the configure ingest molecules, and you want XIF parser and Android analyzer. Alright. I'm in New York, so that's good. I'll go next. I'll deselect, and I'll choose XIF parser, and then I want to find the Android. Where's the Android one? Android analyzer. Right, I want XIF parser and Android analyzer. And I can see next, and then finish. Next, and then finish. It says pay attention to the status bar in the bottom right corner to determine when the ingest modules are done running. Proceed once the processing is done. Bottom right corner. You will now be taken to the autopsy main window. Here we can navigate the data partition of the phone to identify some common artifacts. To begin, click the blue pin by data sources, which will expand and reveal the FEF as seen in item 1 below. Next, click the blue pin beside lab 16.001 to view the partitions on the drive as seen in item 2 below. In the physical images of Android devices, you will see many partitions. This image has 18 partitions. We will focus on the data within one, which is in volume 15, the data partition. Let's expand volume 15 by clicking the blue pin. Within volume 15, you are now able to see several folders that we can navigate. So is this done? I can't really see the lower right-hand corner. Because there's like, oh, maybe if I move this. Okay, so it's still making progress. It's about 2/3 of the way there. Alright, that's done. Let's see. Now, data sources, lab 16, volume 2. Huh, it's lab 18. That's curious. It's done. Alright, let's check. Lab 16001. Data sources. Lab. Is that an 18 or a 16? I feel like that's an 18. I'm not sure why that is. It doesn't have the data. Huh. Expand volume 15. Data FS. I don't think I have a data FS volume. No. Why did I get volume 8? Did it not? Did I do something wrong? Let's try again. Disk image. Next. Oh. Alright, we'll try again. 16. Slash. Browse. Yep. Whoops. Volumes lab 16. Open. Time is correct. Go to next. I want XIF parser and Android. Let's see. Next. Alright, so I chose the wrong one, and that was the issue. So I'll try again. Alright. Okay, that looks like that's finished. Yeah. I'll say finish. Alright, now we're going to expand. We're going to close up 18, open 16, open 15. Okay. Much better. Okay. Most of the data that is valuable to forensic examiners in an Android device can be found in databases and config files. Let's take a look for a few useful artifacts that can help us learn more about the device. Click on the blue pin beside the following folders: data, com.android provider settings database, data, com.android com.android.provider settings. Databases. Settings.db. Autopsy creates references to the current folder and parent folder within the file list pane. Click on settings.db. Next, click on the Application tab, and then select System. Application tab. Okay, and then Table System. Okay. This table reveals device settings such as the sound settings, the airplane mode settings, driving mode settings, and other options. This information will not be necessary in every investigation, but is useful to know since it can provide hints about the phone's state and expected behavior. Take some time to review the options you see here. Okay. System voice alarm. Well, there's a lot of options. Notifications, Bluetooth, mode ringers. Oh, there's so many. Screen off, timeout, emergency tone, call auto retrial, DTMF tone type, hearing aid. That's interesting. TTY mode, assisted dialing, domain switch conf, disable incoming calls, dormant start hour, dormant start minute, dormant end hour, dormant end minute, dormant allow list, airplane mode on, airplane mode radios, airplane mode toggleable radios, screen brightness mode, window animation scale, transition animation scale, accelerometer rotation, something, mid feedback magnitude, indication magnitude, PSM display, background color, button key light, UNA setting, information ticker, contents type, sliding speed, with circle DUA clock, Amazon Cradle Connect, Cradle enable, desk home, screen display, automatic unlock, cradle launch, phone 1 on, phone 2 on, haptic feedback enabled, notification light pulse, set install location, default install location, power sounds enabled, low battery, sound, TFM tone, thick sounds, dock sounds enabled, desk dock sound, desktop unload sound, car dock sound, car unlock sound, lock screen sounds enabled, lock sound, unlock sound, pointer speed, driving mode incoming call, driving mode message notification, driving mode email notification, driving mode mail voicemail conf, driving mode alarm notification, driving mode schedule notification, driving mode unlock screen, driving lock message, split view, mode phone, split view, mode message, and split view mode calendar. Alright, it's a lot of options and settings. Let us look at the security settings now. Begin by clicking on the table and click Secure. Table. Oh, this one. Table Secure. This table contains network preferences and security options. Look at the first 4 rows highlighted in number 1. Bluetooth on, data roaming 1, install non-market apps. These settings can tell whether the device's Bluetooth and data roaming were enabled. It can also tell whether non-market applications can be installed with the phone. This is helpful setting when determining whether a device was compromised. Let us scroll down to row 17. This row tells whether backups are enabled for the device. 17. Backup enabled is off. Let us scroll a little further. Row 29 is lock screen disabled. Lock screen disabled. Tell where the phone's lock screen was enabled. The fact that this is 0 indicates that the phone's lock screen was enabled at the time of extraction. Now look at row 34, which has enabled face lock. This indicates that face lock was enabled. 34. Lock screen options enable face lock. Now there are several more settings and options related to security and network settings in this table. Feel free to scroll through and identify some familiar ones. Now let's look at some information on the check-in.xml file. To do this, first contract the previous folder, and then expand com.google.android.gms. Yeah, that doesn't make a big difference. com.google.android.gms. Okay. And we want what? Shared prefs and then check-in.xml. Shared prefs. And then check-in.xml. And then click on the text tab. Text. In this file, we can find information about the phone, such as the International Mobile Equipment Identity IMEI seen in item 1. This number can be used to find specific details about the phone and is unique to this device. If you scroll to the bottom of this window, you will also see the Gmail account associated with the device as shown in item 2, and the steps to tie a user to a device. Since we found an email address, let us look to see if there's any information about the emails for the account. Let's navigate to the Gmail database. To begin, contract the folder by clicking the blue pin and expand com.google.android.gm and then databases and the mail store. com.google.gm databases. Mail store .db, I think is the one we want. Yeah. Okay, and then click on application. Yes, I did that already. Alright. Let us look at the email message data by clicking table and then messages. The table that appears contains fragments of the emails that are in the account. Let us look at some of the columns that make up this table. The first column, ID, seen in item 1, is the unique identifier for each message in this table. The message ID, seen in item 2, is the unique identifier for each message, and the conversation, seen in item 3, contains a unique identifier for each thread. These values help to keep track of messages and can be referenced by other tables in the database. The from address and to address, seen in item 4, are the sender and recipient of each message. Let us scroll to the right until you get to the data sent MS and date received. Okay. Change time, access time. 5, check some. I didn't see date sent and date received. Maybe I need to go down here? I don't know. Huh. I didn't see it. Extension. Create time, access time. I don't see that. I'm going to change time and access time. I don't see any way to move over. That's okay, just the only page there, so I don't know what they're talking about. Page 1 of 1. Reply to address. Time. Change time. Name. It's not there. Messages. Do I need to go to text? No. Yeah, I don't see how to do that. Just one page. Scrolling can be a little tricky. This is still messages. Wow. I don't see that. No. If you have difficulty scrolling across, select any of the cells and use the arrow key to navigate your way across. Okay? I don't see any way to get any further, so what's this one? Home address. That's just changing the sort order. Can I make this bigger? Will it help? CC. This is really difficult to get. I don't understand how to take a look at that. That's weird. Yeah. I made that large. That is curious. Yeah, I don't really get that. There's no scroll bar. This one has a scroll bar. This one does not have a scroll bar. I'm able to see a scroll bar. Yeah, it's weird. The next column, called Subject, is item 1 in the subject of the email. Right beside that is the column called Snippet. This column contains message fragments. Here you can see the first part of the email messages in the Gmail account. While they are not complete emails, it is really great that we can find the information such as subject, sent, received, attachments, etc. So let us look at another table in this database and navigate to the attachments table. This table contains details about the attachments associated with the emails in this database. We will only focus on a few columns in this table. The first 3 columns are familiar to us, as we saw something similar in the messages table. As you can see, the message ID and conversation columns have similar values to the one in the messages table. This is because the attachments table associates the attachments listed here with the matching email addresses. The row called _ID is unique to this table, however. Let's scroll to the right, until you get to the column called File Name. Alright. Oh, I can choose which ones to display. That's good. Okay, but I'm not seeing File Name. That's weird. Attachments, automatic attachments, download file name. Okay, I can see file names. So I'll get rid of that and that. That. I guess I need to get rid of origin extras. Messages. File name. Alright, so I see file name. Alright. Now track where a file came from. You can trace it back using the message and conversation IDs. Select any of the cells and use the arrow keys to navigate your way across until you reach the column. The next interesting artifact we'll look at is Google Maps navigation history. This database file can provide information about the user's previous trips plotted by Google Maps. Begin, contact the folder called google.com/android.gm. DA destination history. Okay. Databases. Alright. For destination. I don't see a destination. I'm not seeing a destination. Am I in the correct folder? No, probably not. com.google.android.apps. com.google.android. Apps, maps. Databases. And DA destination history. Okay. Click on the application tab. Okay, it's clicked. Let us look at the navigation for Android. Oh, let's go to destination history table. Destination history. Okay. This table contains one entry, but this entry contains a lot of detail. Let's look at some of the columns. The first column is the time and can be converted to a human-readable date by right-clicking in the column and selecting Display as Date. Okay. Time. Display as Date. Time. Better? Not sure what it is. Alright. This is the time entry when the navigation began. That's the time of the latitude and longitude entries in the columns called dest lat and dest LNG, highlighted in item 5. Data in these columns plot the specific location of the destination. Next up is the destination called dest address in item 6. This is the address that the user navigated to. Finally, if you scroll to the right, you will see the source latitude and source longitude called source lat and source LNG in item 1. This is the location that the user started navigating from. The information we identified in this database is helpful since it helps you to keep track of the user's travels. We will look at 2 more data types and then move on to the calls and messages. Let us start with the Wi-Fi data. To begin, contract the folder that's open data by clicking the blue pins. Next, click the blue pins beside MISC and Wi-Fi. Contract data, expand MISC, and then click on expand Wi-Fi. And then choose WP Silicon Conf. This configuration file contains information about the wireless adapter and the cell phone as well. Look at the data highlighted in item 1. Here you can see the wireless interface, the device model, manufacturer, and serial number, and hexadecimal. In item 2, you will find the saved Wi-Fi connections, including your SSID encryption and the passphrase. Let us look at one last network connection artifact. This is the SIM card data. To begin, contract the MISC folder, then click on the folder called System, and then SIM card called DAT. MISC. We'll go to System, and then did I get that correctly? System, and then I'm looking for SIM card .dat. I don't see SIM card .dat. All right, go to System, and then still don't see SIM card .dat. Try again. There it is. Okay, and I'll click on text. And look at, as you can see in item 5, the details of the previous SIM card are listed here. It provides the integrated circuit card identifier, ICCID, and the phone number, as well as details about the SIM operator, and the country. The details of the current SIM card, if applicable, can be seen in items 6 and 7. The Unix time of the SIM card was changed or removed. So far, we've looked at lots of different database and configuration files and seen the types of data inside them. In the next exercise, we'll take a quick look at the processed data that the ingest modules uncovered. 2. View the extracted mobile artifacts. We will look at the artifacts that this tool extracted for us and see what the database is, the information is pulled from. Let us begin by contracting the tree item called data sources, and we'll expand results, extracted content, and then logs. Contract data sources, results, extracted content, and then logs, like call logs. Results, extracted content, and then call logs. The call logs will appear in the listing pane. Let's look at the columns. The first column is called the source file, seen in item 1. It's the file that the call logs were taken from. This file is the logs.db and is located in that path. The column called toPhoneNumber, seen in item 2, contains the phone number that received the call. 2 columns to the right of that, called start date time and end date time, as seen in 3, are the start and end dates of time and times of each call. The next column is the one called direction, as seen in item 4. It tells whether the call was outgoing or incoming. Next is the name column. Item 5 is populated with a contact name if it is saved or known by the device. Scroll to the right to see the last column called From Phone Number in items 1 and 2. Okay. This column tells the phone number that initiated the call. This data can always be verified by navigating to the source or by clicking the Application tab, which will open the database file. Let us look at 2 more data categories. Click Installed Programs as seen in item 1. List of installed programs will appear in the listing pane. Let us look at the columns. The first column, as seen in item 2, is the source file. This tells us the name of the file that the data is pulled from. The column seen in item 3 is the name of the program. Finally, in item 4, the date time column can tell when each specific program was installed. Scroll through the list and see if you're familiar with any of the programs. Make a note of all the social media applications installed. The last artifact we will review is the Messages category. Click Messages. Like before, the results will appear in the listing pane, and the first column in item 2 is the source file. The column called Direction, seen in item 3, contains the direction of each message, like in the call logs. The next column, toPhoneNumber, as seen in item 4, lists the destination phone number of the message. The column that follows, as seen in item 5, is the date-time column. This tells the date and time the message was received. Next is the read status, as seen in item 6. This tells whether the message was opened or not. The column called Subject, in line 7, lists the subject of the message if one was given. Finally, item 8 is the text of the column and contains the body of the message. Let us scroll to the right in this little scroll bar. You will see, scroll bars at the bottom, you will see the message type column, as seen in item 2, which tells whether this is a short message service, SMS message, or a multimedia message. Since this database can contain both. The column to the right of that, as seen in item 3, is the thread ID and contains an identifier It is used to link messages to a specific thread, as we discussed when we were looking at the email fragments. The last column, called From Phone Number, seen in Item 4, lists the sender's phone number. As you can see from the long list of databases and the data within them, there are many important artifacts that can help you to confirm or deny certain findings. We did not review the files that are stored on this device, but feel free to review them. You can find things like photographs taken, files downloaded, deleted files, and hidden data. In a more advanced course, we can go in depth into some more useful artifacts that are not readily available or easy to interpret. Now, at the end of the lab, close it up. Thank you.